Everyone, and today for our challenge for our Sunday coding challenge, we're going to go over one of the most commonly asked interview questions that you could possibly get in any of your interviews. When I was interviewing for my first couple of jobs, this is actually one of the ones that I got, and it can be kind of difficult to think about, but we do have simple solutions for them. So basically, it is containing duplicates. If you're given any type of structure, come up with a way to determine if your structure contains duplicates. In this case, we're going to be working with arrays. And you can choose any language, and you can use anything within that language that you want that will give you the fastest time in both complexity and space for your solution. So for this, we are given an array of integers. Write a function that determines whether the array contains any duplicates. Your function should return true if any element appears at least twice in the array, and it should return false if every element is distinct. So if we really talk about this, what we need to do is in our array, we have a couple different ways that we can go about this. So we have solution one, which is we can take array A and array A again, and basically if this equals 1, 3, 3, and this also equals 1, 3, 3 because they're the same array, we could basically have, index A or index I and index J. And what this is going to do is if I bring A equals 1, 3, 3, what I'm going to do is basically say, I'm going to start index I right here and J right here. And now I'm going to test for equality. If I equals J, then we know we have a duplicate. If I does not equal J, so if I equals J, we return true, saying we have a duplicate. If I does not equal J, we continue our search. So we're gonna continue the search. So if I does not equal J, then we're going to increment J just a bit. So J now goes there, and J is no longer here. So J moved to the next index. Now we're going to check I with J sub 1. And we're just going to check here if I is equal to J sub 1, then we will return true. If I is not equals J sub 1 and J sub 1 is at the end of the array, then we increment I over with our new starting port of J being I plus 1. So this comes down to a complexity of O of n squared because we're going through the array of size n twice. Or we're basically going from inside to outside to outside of the array twice. And that's really going to be a stinker in this. Another one that we could do, or at least in time-wise, complexity and time are the exact same. When this comes to space, we have O of 1. We're not changing the space. We're not doing anything with our structure. We're simply looping through it twice. We're doing 2 for loops to go through it. So our space is O of 1. So in total, this combines to O of n squared, since we add these together. We have O of n squared. Our solution 2 is to use internal Java methods to check distinct values. And by this, I mean there are some structures out there that do not contain duplicates. So for this, not containing duplicates, we have sets and hash maps or hash sets. They do not contain duplicates. But we can also use, if we're running in Java 8 or higher, we could use streams dot distinct method to get our values all distinct. And then we could just check length. And so what this is going to do is we're going to have a complexity of O of 1 or O of n and we're going to have a space big O notation of O of n as well. And I'm going to explain, but our end result is O of n. So we're going to have complexity of O of n and space of O of n. So what we're doing here is we're going to go through our array once and basically put it through a stream and only keep the distinct values of it. We don't know, it's going to have to go through every single item in the array, which means we're going to have to go of n the first time around to put it through the stream. Now, our end result of putting it into another array gives us a space complexity at worst case scenario O of n, meaning that we're going to have to put every single item into a new array. So we're going to have to put n items that we get into an array that is of n length. Best time that we could do that is if we have one value. So it'd be O of 1. So our space is O of 1. It's constant. We basically say, well, all items are a repeat of each other. So therefore, we're making an array of size 1. And that would give us a feedback or space-time of O of 1, which is constant. But that is best case scenario. On average, you're going to be closer to n. So average case and worst case are O of n, therefore we go with O of n. We actually always go with worst case scenarios, so we're going to go with O of n case. And then checking the length is constant time, so our check for that is constant, so it doesn't really add into our overall complexity. So this is O of n. And I believe O of n is the best that we could do. But if you aren't allowed to use internal Java methods or you don't know the internal Java methods, then I would highly suggest going with solution 1. It's not too bad, but it isn't the best. So with this, let's switch over to the code and see how both solutions look in the code. So for solution 1, we're going to go in and we're going to create 2 for loops. So we're going to say for int I equals 0, I less than a.length, I plus plus, and then we're going to make another for loop inside of that. I int j equals 0 is I plus 1, I less than, or j less than a.length, j plus plus. And we're just going to say if I equals j, return false, return true. And at the end of this, we're just going to return false. And we're going to run our sample tests. Oh, 5 out of 10 pass. Why do only 5 out of 10 pass? Ah, my bad. If ai equals aj, there we go. Sometimes I forget how to use arrays, but this is how we get the space-time complexity of 1 and the time complexity of n squared. So we have one for loop, which is n, and inside that for loop, we have another n. So we have an n times n. Therefore, we get n squared. So this is the answer to solution 1. And you see we pass all 10 samples. If we submit it, challenge is not currently active. I'm just going over an old challenge. But if we submit it, this should, oh, it's incorrect. We exceeded time limit on test 20. Now, this is why complexity and also time complexity and space complexity come into play. We exceeded execution time limit. Therefore, we look at the constraints. So the length of A could go up to 10,000, I believe. Either 10,000 or 100,000. And we have to check all these numbers. These numbers don't really matter for what they are inside of A, because that's going to give us a constant give and take. The length is going to be the complexity here that we run into issues with. So if we run into worst case scenario, we have 0. Best case scenario, the length is 0, then we're all golden. Everything's good. If we are at the other edge case of 10 to the 5th, and we're going through that twice, we run into a really big issue there. So these are some issues that come into play. The time to get through this is probably too long. It's only missing 1 test, so that is probably the edge case. So this isn't fast enough. So we have to move on to solution 2, which is if we make int b equals arrays dot stream dot and we have to give it the array a dot distinct dot to array. This will return to us an array of b with distinct values. Then we just check if b length less than a dot length, then we know that there was a duplicate. Otherwise, we return false. So if we run our sample tests, we pass all of our sample tests, and then if we submit it, everything seems to be going good so far, and we got it correct. We fit within the constraints of our time and our space. So we're all good here. And usually our execution time limit is 3 seconds. If we take more than 3 seconds to execute, something is wrong. We're doing things too complex, and we need to shorten it. So for this is O of n. We pass in the array A into the stream. We then only keep the distinct values, and we put it into array B. So our space complexity is O of n. Whatever size we get in A, we'll get in B on the worst case scenario. And then we just check the length of each, which is a space-time complexity of 1. And then we just return true or false from there. So for this, our space-time complexity is O of n. So that's how you solve this issue. If you do get this in an interview, I would highly suggest you putting it through a stream to get the distinct values and then setting it to an array. Well, thank you very much for watching. I hope you guys have a good day. See ya.